2. All right, so we talked about how to find slope. Okay, earlier I talked about equation of a line that is the best form of the equation of a line, in my opinion. All right, and that is the slope-intercept form of a line. Okay, we've already seen it tonight. We just haven't called it that. All right, but if you have y is equal to, so y is all by itself, then you're in slope-intercept form. Okay, slope-intercept form is this form right here. Y is equal to mx plus b. So if your y to the left, you have a number in front of x, then plus or minus a number. All right, if it's in that form, which is nice and pretty, it tells us two things about the line. All right, the number in front of x. Okay, that m, we already talked about, that is your slope. All right, and the number over here by itself is the y-intercept. Okay, so you can look at the equation in this form and quickly tell what's the slope and what's the y-intercept just by looking at the equation, if it's in that form. All right, so for example here, if I want to find the slope of this equation, f of x, which is the same thing as y, is equal to 2/3 x plus 4. All right, the slope is the number in front of the x, so what is my slope here? 2/3. There's your slope. And in section 5, we'll learn how to use that to graph. Okay? On this one, we got the function f of x equals negative 4x plus 6. So what's your slope on that one?
Negative 4.
Negative 4. It's that number in front of the x. That is your slope. All right, it didn't ask for it on these, but what's the y-intercept for the first one? 4. All right, so the ordered pair is 0, 4. All right, and then the y-intercept of this one down here? 0, 6. And if you have those two pieces of information, we'll see we can graph it really quickly without having to plug in to find a whole bunch of ordered pairs. All right, the problem is it's not always written in that form. Okay? For example, this is the standard form where it has something x plus or minus something y is equal to a number. Okay? But we can get it in that form, all right, by simply solving for y. Moving stuff over that's not a y and dividing by the coefficient of y. All right, so I want to bring this 3x over, so I'd subtract it. All right, when you do that, that leaves me with a negative 4y is equal to negative 3x plus the 4. Notice I don't put them together because one's, and it gives us the slope-intercept form of the equation. Y is equal to a 3 over 4x minus 1. What we did there? We brought the x part over by subtracting it over. All right, and we divided everything by the coefficient of the y. Don't lose a negative if it's in between there. That stays with it. Okay, and then the negative 3 divided by negative 4 is positive, because negative divided by negative is positive. And the 4 divided by the negative 4 gives me negative 1. So once it's in that form, what is my slope?
It's 3 over 4.
3 over 4. And my y-intercept?
0, negative 1.
0, negative 1. All right, so try your practice. See if you can do the same thing. Manipulate that equation to put in the slope-intercept. All right, I got my slope of 2/3, y-intercept -3, 0, -3.
Just, I got the 2/3, I got the -3. How did you come up with the 0?
Just the y-intercept is always going to have an x value of 0. So just put it there. Remember when we were finding the y-intercepts, you'd let the x be 0.
Okay.
So 0, -3. All right, so when we solve this one out, okay, so I have the 2x minus 3y is equal to 9. We're good so far. That's just rewrote it, right? Subtracted the 2x over. That gave me a -3y is equal to -2x plus the 9. Okay. And then we divide everything by that -3. So the -2 over -3 became positive 2/3. And the 9 divided by the -3 gave me a -3. Got it? All right, so we've talked about slopes. We got positive slopes, which go up from left to right. And negative slopes do what? Go down from left to right? Okay, so two other slopes we need to talk about. All right, and they are special cases, or more special cases, when you have horizontal and vertical lines. Okay, do you remember x equals 2? What kind of line is that?
It's vertical.
You remember x equals -5, that means here's my -5 on the x-axis, vertical line. All right. Well, y is equal to, I find the y value on the y-axis, and draw the horizontal line. Now, these have neither positive or negative slope. They're not going up from left to right, they're not going down from left to right. This one, all right, it's going up and down, but is it going over it all? No, so this has a rise, but it has no run. All right, if you have a rise and no run, okay, we say this slope is undefined. Its slope is undefined. Because technically no run means 0, and you'd be dividing by 0, which is, you can't do, it's undefined. All right, whereas this one, it has no rise, but it has a run. All right, so you got 0 on top divided by, so this has a slope of 0. We go to the gym, which I don't, and get on the treadmill, which I don't. Okay? On treadmills, on fancy treadmills at least, you can change the elevation, so it's harder or easier to walk on. Okay? If I were to get on a treadmill, I'd want it to be at a setting of 0, which means I'm flat. Okay? So 0 slope, notice I'm flat. I can walk across 0. Okay? But there's no way I can walk up that unless I'm Spider-Man. Okay? So undefined, can't walk up undefined. I can walk on 0. Get with a 0 slope. Can't walk up undefined. All right, the next slide here is a little helpful hint there. Okay, slope of 0 and undefined are not the same. Verticals have undefined. Horizontals have slope of 0. And it's just kind of a synopsis of going up from left to right, positive going down from left to right, negative. Okay, so you can always kind of check yourself when you're working, make sure you've gone the correct way. Now, even if they have the same sign, they're both positive or they're both negative, okay, we can compare their slopes. Okay, for example, this one, the blue line here, is the 1/2 x plus 1. while the red line here is 5x plus 1. So notice the slope of this blue line. What is the slope of this blue line? 1/2. Notice it's over here in blue. Whereas the red one or the pink one has a slope of 5. All right, which one do you say is steeper than the other?
5.
The 5 is steeper than the 1/2. Okay, so in general, for positive numbers, the higher the number, the steeper you are. Okay, the higher the number. If this slope was 10, that's a really steep. All right, a slope of 1/10 would be really flat. Now we can compare the slopes of two lines, and we've talked about whether they're parallel, perpendicular, or neither. Somebody already said the word parallel earlier. Parallel means they have the same slope. Okay, perpendicular, that means they meet a 90-degree angle. All right, and if you notice the letters over here, one of these slopes has a slope of what they say is A over B. The other one has a slope of a negative B over A. Now the box says non-vertical lines are perpendicular if the product of their slopes is -1. Okay? Easier way of thinking about that, two lines are perpendicular if their slopes, one of them is flipped over, and they have different sides. It's called the negative reciprocal when we get mathy with it. Okay, so if they're fractions, okay, one is just the other one flipped over, one of them is positive, one of them is negative. All right, so let's look at these next problems. If you want to compare whether these lines are parallel, perpendicular, or neither. Okay, first thing we got to do is find the slope of each one of them. All right, so let's find the slope of this one. 3x plus 7y is equal to 4. Just like we did in the last couple of examples. Subtract the 3x over. I get 7y is equal to negative 3x plus 4. Divide everything by 7. All right, so that in slope-intercept form is y is equal to negative 3 over 7x. All right, ugly y-intercept for this problem, I don't care what the y-intercept is. I'm just looking at its slope. All right, that's all that first one. All right, so let's look at the second one. 6x, I'm going to move it up here for my people in the back. Subtract the 6 over. So 14y is equal to 6x plus 7. Divide by
It's 207.
14.
They have the same shape.
All right, when I simplify that, that gives me y. 2 will go into both 6 and 14.
3,
2 will go into 6 3 times, so I got negative 3
7,
and 7x. And this will actually reduce to 1/2. All right, so compare the two. Do they have the same slope?
yes.
All right, do they have the same y-intercept?
No.
No. Parallel lines have the same slope but different y-intercepts. So are these two parallel? Yes. Parallel because they have the same slope and their y-intercepts are different. Same slope, different y-intercepts. All right, let's look at the B one together over here. All right, if I move that one over, x plus 3y is equal to 2. I'd add the x over. You get x plus 2.
Whatever.
I divide the 3. Alright, important note here. What number is in front of the 1? Or setting? What number is in front of the x? A 1. So that's a 1 over 3 is my slope. And then the 2/3 is my y-intercept. Okay? Alright, we look at the other one. Alright, the 2x plus 6y is equal to 5. I subtract the 2x over. Alright, I get 6y is equal to negative 2x plus 5 divided by 6. I get y is equal to, when I reduce,
Negative 1/3 x
negative 1/3 x
plus 5.
plus 5, 6. So I compare. Are they the same slope?
No, big.
No. Okay, they have different signs, but is one the other one flipped over?
Yes.
They're actually the same fraction, aren't they?
Yes.
Okay. So this one will actually be a
Neither.
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 Okay.
Neither.
For reciprocals, or for perpendicular, one of them needed to be 3 over 1. Okay. And they have different signs, and then one of them needs to be the flip of the other.
Can you explain that?
Okay. In order for perpendiculars, okay. Perpendicular, this would be an example of perpendicular. If you had y is equal to, let's say, 1, I'm going to make it negative since I have a sign there, negative 1/4 x plus 2. And y is equal to 4x plus 3. Okay? Notice this slope is a negative 1/4. This slope is a 4 over 1. So one of them is the other one flipped over. It's this reciprocal, and they have different signs. So these will be perpendicular because one is the flip of the other, and they have different signs. Whereas the one we just got through doing, they both had a 1/3, so they're not going to be perpendicular because for them to be perpendicular, one of them needs to be flipped over. So for perpendicular, two things need to be true. Different signs, and one of them's flipped over. Okay, so try the practice. Let's see if we see a perpendicular one on that one. Okay, the one down here at the bottom. Perpendicular, flipped over, and one of them's different side.
So that,
Yes. You don't have anything really up. Don't forget the answer.
Right.
Don't forget the answer. You're positive in this area, right about that. So, we'll just say about 2 months. So, one positive, one negative. This one's positive.
Equals.
That's a flip one over there. The X minus C. Those of you that have finished already, check. Good. All right, so 2 things on these. First off, you have to be able to solve the equations correctly. All right, that's one problem. If you don't do that, then you can't even really compare them. All right, so these are the equations. This one is this one solved for y, and the 2x plus y equals 3 is solved here. All right, and so you notice that 2 things that you have to check for perpendicular. Do they have different signs? Yes, one's positive, one's negative. And if you flip 1 over 2, do you get 2 over 1? Yeah, so they're both different signs and one of them's flipped over, so perpendicular. Over here, once you solve this one out correctly, you get y equals 4/3 x minus 2/3. Y equals 4/3 x minus 1. And so these, they have exactly the same slope, so they're parallel. Okay, if they're not exact, or they have different signs and one of them's flipped, then it's going to be neither. Okay, so
Yeah, I got it.
so when you bring that one over,
I got a negative 2.
all right, you start off negative, that's correct. All right, so you have a negative 3y is equal to a negative 4x
Oh, okay.
plus 2.
Oh, yeah.
But then when you divide by the negative 3,
Okay.
that becomes
Positive.
back positive. Yes.
the question, I see the wire in the 1/2, I came down with the 1/2. But, that three dash right there,
Okay.
that's what I need to know.
All right, so on that one, first thing you do is subtract the x over, which I got a negative 2y is equal to a negative x plus 3. We good there?
I can't see it right.
You can run it over.
Yeah.
All right. And then I need to take the negative 2 and divide it over. So when I divide the negative 2, I divide everything by the negative 2. Cancels out here. This one had an understood negative 1, so negative 1 divided by negative 2 gives me a positive 1/2 x, which you said you got, right? And then the 3 over negative 2, you can put in your calculator, get negative 1.5, or just since it's a positive divided by negative, I'd change that to a minus, and then just rewrite the fraction.
Okay, so you just rewrote it.
Just rewrote it, and since it was positive divided by negative, I just put a minus instead of the positive and negative one.
Okay, so you just left it, you didn't do nothing with that.
I didn't do anything. All right, that is slope. And now you get to see, if you're watching the video, a little brief time of me talking while I open my computer and stop the video.